Okay, so for this last video, we're going to go in and once again find the equilibria points and then study their stability. And there'll be quite a few equilibria points for this. So again, the first step of doing this is to set each differential equation equal to 0 simultaneously, and then solve for the ordered pairs x and y. So if we set each one equal to 0, in the first equation we can factor out an x, leaves you with 2 minus x minus y. Second equation, we can factor out a common y, leaves you with 5 minus y minus a 4x. Now, each of these equations tells us something different about our solutions. So let's first take the top one. And again, these are still equal to 0, of course. So for the top one, if we take x to be equal to 0, then we could take that information and substitute it into the other equation. That's going to make either y is equal to 0 or 5 minus y is equal to 0, which in turn says that y is equal to 5. So when x is equal to 0, we have two equilibria points. We've got 0, 0, and we've got the point 0, 5. Now let's take the second part of this equation, which is the 2 minus x minus y, and substitute that into the other equation. So that's going to give us our 2 minus x minus y equals 0, tells us that y is equal to 2 minus x. So we're going to have y, which is 2 minus x, times 5 minus, parentheses, 2 minus x minus 4x is equal to 0. Again, we're just substituting 2 minus x in place of the y's in that second equation. All right, so the first factor tells us that x is equal to 2. The second one, if we distribute, we get 5 minus 2 plus x minus 4x is equal to 0. So that's 3 minus 3x is equal to 0. 3x equals 3, so that makes x equal to 1. So either x is equal to 2 or x is equal to 1 in that case. So we've got the ordered pair 1, we don't know, and 2, we don't know. To get the y numbers, we go back to our original, which is y equals 2 minus x. So when x is 1, 2 minus 1 also makes 1. And then when x is equal to 2, 2 minus 2 makes 0. So that right there is going to be the 4 different equilibria we have for this nonlinear system. And then the next thing for us to do, of course, is to find our Jacobian matrix, which again is our matrix of partial derivatives. So our Jacobian matrix is going to be, taking the first partial derivative, we're going to have 2 minus 2x minus y. And then for the y partial, we're going to have just a negative x. And then for the second one, we take our x partial, just picks up a negative 4y. And then taking the y partial, we've got a 5 minus 2y minus 4x. So that is our Jacobian matrix to analyze these different equilibria points. So let's actually take care of one of those now. Let's do the 0, 0 since it's so easy. The Jacobian for 0, 0 is going to just be a 2, a 0, 0, and a 5. And again, this is a diagonal matrix, so therefore we can just read off the two eigenvalues as positive 2 and 5. And because those are both positive, that means that 0, 0 is going to be an unstable node. All right, and now we'll go through and find the other equilibria points next.